Welcome, my dear students. I am Dayakar, Associate Professor, Department of Civil Engineering, Bharat Institute of Higher Education Research. Today, I am going to discuss about the course Ground Improvement Techniques. In that, I am going to discuss about dewatering techniques, which comes under Unit 2. Dewatering. What is dewatering? Dewatering is a term for control of groundwater by pumping. On construction sites, it may be known as construction dewatering, whereas in mines, it is called mine dewatering. So the process of dewatering can be defined as pumping from wells or sumps to temporarily lower groundwater levels. And also, this enables the excavations to be done in dry and stable conditions below the natural groundwater level. This picture shows a typical dewatering well construction wherein we have the pump and we have the casing pipe, and this is the pump pipe, and this is the PVC casing, and this is the ground surface, and this is the natural groundwater table. And now when the pump pumps out the water through the pipe, and it is connected to the header pipe so that it can be discharged through the header pipe to a longer distance. Thereby, the natural groundwater level reduces here, so we can do the excavation works or civil engineering applications there. What for we are going for this dewatering? During construction stage, we won't have a dry excavation. Of course, from the ground level, if we have 1 meter or 1.5 meter or 2 meter, no problem. But whenever we want to go deeper excavation, then we may come across with the groundwater table. So in that case, we need to dewater or bring down the groundwater table so that we can do the excavation in right condition. So it will be uh, safe. Also, in some cases, we can reduce the lateral loads where we have gone for sheet piling or bracing in excavation. Also, we can improve the supporting characteristics of foundation material, that is the soil material. In case of slopes and side hill fills, we can increase the stability of the excavation by lowering the groundwater table. Also, we can reduce or cut off the capital rise to prevent piping and cross heaving in case of pavement. And in case of tunneling operation, we can reduce the air pressure by dewatering. How we can do this dewatering? There are many techniques followed for dewatering, but the general techniques followed are some pumping, well points, deep wells, and ejector wells. Yes, we can see one by one. Before that, we have to see what are the various factors controlling a particular technique, like sump or deep well. So those factors are what is the nature and permeability of the ground. Ground means the soil. Similarly, geological conditions of soil, whether it is a fine grained soil or coarse grained soil or silt or hard rock, and what is the area to be dewatered, or what is the area of extent to be dewatered, and what is the depth of water table to be lowered, because some require only few meters, maybe 5 or 6 meters, or in some cases, in case of mining, we have to go for maybe 20 meters or 30 meters. So that should be considered. And amount by which it has to be lowered. That is, what is the rate, whether it is very quick or very slow, and what are the proposed methods of excavation. Suppose we go for a sheet piling or a steel casing, then dewatering may be required in the initial depth. Whereas if you want to go for mining, then we have to go for deeper dewatering or lowering the groundwater table to a very great depth. And also we have to see what is the proximity of existing structures. So these are the various factors which we have to consider. Sump pumping is the simplest dewatering technique, where we have a structure called sump. It is nothing but it is a merely hole in the ground from which water is pumped out for the purpose of removing water from the adjoining area. They are used with ditches leading them to large excavations up to a maximum of 8 meters below the pump installation level. For great depths, a submersible pump can be used. So shallow slopes may be required for unsupported excavation in sills and fine sand. In gravels also, the sump pumping is more suitable. If there are existing foundations in the vicinity, pumping may cause settlement of these foundations. So we should be very careful in pumping. So this picture shows the simple sump pumping technique, where we have the sump, and then inside we have the suction pipe with the filter medium, and this is the pump. It is pumping the water and it is sending the discharge to a larger distance. Now this is the initial water table, and because of the pumping of the water, the initial water table goes down, and this is called drawdown curve. So we can see the water table, groundwater table is lowering, thereby giving way for the excavation activities. The sump is preferably lined with the filter material so that we can pump out only the water, not the soil along with that. And this is very useful in case of what a sloping structure, so that the initial water table, because of the excavation, can be lower. So this sump pumping is the simplest one, whereby we can engage this type of pumping in in all slope excavations, where we need to dewater the existing groundwater. So this shows that there is a sump and the water is pumped out, and it is drained to a drain line. From there, it is sent to the the header pipe. What are the disadvantages and advantages of this sump pump method? It has got the advantages because it is widely used, and also it is more economical because it does not require any sophisticated equipment. Moreover, this can be applied in almost all the soils and also rock conditions, and this is the most appropriate method in situations where boulders and massive objects are met with in the ground. Greatest depth to which the water table can be lowered by this method is about 8 meters. So more than that, we cannot go for this sump method. Let's say we have the following disadvantages, where the groundwater flows towards the excavation with a high head or a steep slope, so there may be a risk of collapse of the sites. So that is the main disadvantage, because the sites are not secure, they are not bracing the sites. That is why we are going for the slope. And we are also, if you go for open or timbered excavations, the risk is there for the instability of the timbered excavation. because when you pump out, the water is this water is pumped for a longer distance, thereby the sides may collapse. That is the main disadvantage of this method. The next method is well point system for dewatering. This is also widely used method for reducing the groundwater table. Wells are systematically drilled around the construction area and a submersible pump is placed into the well. This appears to work effectively for many projects, especially those building projects that require excavation for the basement. Because if you go for a multi-story structure, you may go for single basement or double basement. In such cases, this well point system is necessary to deepen the groundwater table for a great depth of 10 to 15 meters. Here, the setup and procedure of working is a well point is 5 to 7.5 centimeter diameter. It can be a metal casing or a plastic pipe. This is given into the ground and it is perforated and covered with a skin. The lower end of the pipe has a driving head with the water hose for jetting. Well points are connected to 5 to 7.5 centimeter diameter pipes known as riser pipes and are inserted into the ground by driving or jetting. The upper ends of these riser pipes lead to a header pipe which is connected to a pump. So the pump will be pumping the water from these riser pipes and it will discharge to a longer distance. So because of the pumping, the groundwater is lower because drawing of the pump is done and discharged through the header pipe. These well points are usually placed at a spacing of 0.75 meter to 3 meter, depending upon the groundwater table and depending upon the amount or the rate at which you want to lower the groundwater table. In grass spacing required may be too close or impracticable. In clays, it is also not used because it is too slow. In case of silk and silk clay mixtures, the use of well points are aided by the upper compacted clay seals and sand filtered boreholes. Upper clay seals help to maintain higher suction pressure and sand filters increases the amount of discharge. This picture shows the simple well point system, that is single stage well point system, where we have the ground level here as well as the existing groundwater table or original groundwater table. And when we install this well point here, then the pumping of the water from this well point lowers the groundwater table in this way. This is called the riser pipe, which is connected to the header pipe to the pump. So here in this picture, you can see this is the original water table, and when the water is pumped out, the water table is lower in this pump. This is the drawdown curve, and because of this lowering, we can do the excavation process here. So here you can see this is the header pump and this is the original water table. This is riser pipe and this is the well point. So because of the pumping of the water, the groundwater table lowers. This picture shows clearly how we can excavate by doing the water technique using the well point system. So this is sandy loam and below that we are having the clay and below that we are having the silty sand, and then fine sand, and then gravelly sand. Now we want to have a tunnel at this location, which is well below the existing ground level. So we are going for this step-by-step excavation where we can go for this well point system, and we can pump out the water, thereby the existing water table is lowered. So because of the lowering of this groundwater table, the excavation is possible and the construction of this tunnel is possible, and thereby we are able to complete the construction. So this is the schematic picture of multi-stage well point system, where first we are lowering the groundwater table from this level to this level by this stage or this system of well points. Then the excavation is done, and then next level or next stage of well, and then further the groundwater table is lowered, and then excavation is done, and further third set of wells or pumping system, thereby the required depth is reached, so that the required construction is done. So this is the actual picture of this well point arrangement, so that you can have the header pipe, and it is connected to the various well points or riser pipes, so that the pumped water can be taken to these header pipe and discharged at a very long distance. Thereby, at that place, we can have the required lowering of the groundwater tip. Now, what are the advantages and disadvantages of this well system? Advantages is very effective in sandy soils. It provides drawdown up to 4 to 6 meters in sand and 4 meters in silty soil. Whereas this is relatively cheap and flexible. The installation is very rapid, and water is filtered and carries little or no soil particles. That is the main advantage, because we are having the strainer as well as the filter. So we are pumping only the water, thereby the soil is not sucked. And there is a less danger of subsidence of the surrounding soil, ground soil, which is in open sump. It may happen when you pump out the water, the slopes can subside because of the pumping of the water. Whereas in this well system, we are having the riser pipes, which is a protective layer, or it is a protection for the soil, so that the water can be pumped out without any danger. But the disadvantage here is the effective drawdown is only 4 to 6 meters. In case you want to go for more than this one, then it is what not possible. That is the limitation. And also, when you want to go for a deeper depth, in that case, you have to go for only multi-stage of well systems. Now, normally, the spacing of this well point system varies depending upon the soil condition. Suppose if you have silty sand, then the spacing could be around 1.5 meter to 2 meter. Whereas if it is a sandy gravel, then it may be from 1 meter to 1.5 meter. Whereas if it is a fine to coarse gravel, then it may be zero point 0.5 to 1 meter. Okay, so this is because the discharge or the yield will be more in case of coarse gravel, whereas in silty sand it may be slow. So as we have the limitations of these well systems to only lower the groundwater table to a depth of 4 to 6 meters, if you want to have more a deeper depthing of groundwater table, we have to go for another method, that is the deep well system. Deep well system consists of one or more individual wells. Each well has its own submersible pump at the bottom of the well shaft. So that is the difference of well system and deep well system. In well system, we can have the riser pipes installed at the spacing of 1 meter or 1.5 meter, whereas the deep well system, it is a deep bore well, and each well is provided with the submersible pump. So this is suitable for pumping large volumes of water, and we have highly permeable sand or gravel area. So in these things, we will be having what water yielding very quickly. So there we have to go for this type of deep well system. And spacing of deep well point system also can be changed. Normally, individual wells are spaced at an approximate distance of 15 meters, that is 50 feet. Whereas in case of well system, we have seen that it is only 1.5 meters. However, depending on the soil conditions and deep watering plan, the spacing may vary. Okay, so that we can find out what is the yield, and accordingly we can vary. And what is the dewatering capacity of deep well points? Actually, this individual well has the capacity of 2,100 to 300 gallons per minute. Okay, that is in case of that is FPS units. You convert that to liters, then you can find out how much liters. Also, the deep wells can lift the water. That is a very great depth. It can lift the water. That is 30 meters. From 30 meters, to lift the water to the ground level, and then it can pump it to what the header pipe, and then to a longer location. So you can have a single stage pump with within this aquifer. That is, in the aquifer, we have the continuous supply of water. And the deep well points require no pump, as the water is forced to the surface by its own pressure. Okay? So this is the advantage of this deep well system. So this picture clearly shows how a deep well system works. So it will be having the borehole, and it will be having the filtered sand, and it will be having the electric cable on the screen, and at the bottom we are having the submersible pump. And there is a check valve to avoid any return of the water, and this is the riser pipe through which the water goes up, and this is the bentonite seal, so that we can pump out the water here, and then here the sides can be stable, and this is the backfill, and the entire thing is properly sealed. Now this riser pipe is connected to the discharge pipe, through which water is what coming out, or water is discharged. And this is having the cable where we have the electric control panel. And this is the actual picture where this is one of the deeper system, where every setup is attached, and then the water discharge is sent through the header pipe, and it is taken to a longer distance. What are the advantages of this deep well system? So it has no limits on drawdown. So we can bring out the existing groundwater table to a very great depth. And in this system, only fewer wells are required than the well system, because it is deep, so we can take the drawdown to a greater depth. But the disadvantage is it is very, very expensive to install. That is the only disadvantage is ditches and trenches. Ditches are nothing but small excavations. Ditches are formed in a pre-planned manner, allowing groundwater to flow in the surface in the deeper level trenches. And here the perforated pipes are placed in the trenches and the groundwater extracted through these pipes to be filtered. These trenches were particularly common in infrastructure network projects. Sometimes graded aggregates or geotextile layers are also used when laying out these pipes. This is the picture which is showing the ditch. That is, this is the original groundwater level, and here we have the sump pump interceptor ditch. Okay, and here, because of the water flowing through this ditch and extracted from this ditch, the existing groundwater or original groundwater table is lower. Thereby, we can do the excavation here. And here, there may be a what the impermeable layer. So this is how the ditches work. But the advantage and disadvantage of this technique is it is very inefficient. You don't require sophisticated equipment. Only thing is you have to excavate and form a ditch or a drain like structure. And this can be used only for shallow groundwater. Okay, and also it is very effective in controlling groundwater after casting the foundation, because we are going to have the uh, foundation cast and this concrete is there, so easily we can separate the water which is oozing out. But this is having the disadvantage of obstructing the traffic. Suppose if you are doing this in the highway, then the traffic will be obstructed. And also the groundwater lowering will be done only for a very shallow depth, not for a deeper depth. And it is not effective in case of fine grain soil. Only in case of coarse grain soil, this is effective. That is why we have to go for the next system, which is called educator system or ejector system, where we can pump out the water with pressure. That is called jet educator system or ejector system. This is most advanced method where we are using the vacuum. So we use the vacuum by the pressure of the water inside the well point, so that with high pressure the water rises. Okay, so when it rises, then the even from the fine grain soils also you are able to pump out the water, thereby the groundwater table is lower. So here we have 30 to 40 diameter pipes or riser units, and then in that pipe high pressure supply of water is done with the help of a venturi tube. Okay, so because of the venturi action, the high pressure is there, and because of this high pressure, the vacuum is created, thereby the water is sucked even from the small pores of the soil. The advantage of this dedicated system is that in operating many wells from a single pump station. That is, it can be connected to many well points with a single pumping station, and also the water table can be lower in single stage or in one stage from a depth of 10 to 45 meters. That is the main advantage. And the procedure is we have the supply pumps at the ground level, and which feed high pressure water to the ejector head through the supply main. And the supply flow passes down the well through a nozzle that is called venturi, and because of that nozzle with the high pressure water, it creates the vacuum at the bottom. So because of the vacuum creation, it extracts the groundwater, and large amount of yield or large amount of water is discharged. So that is the main advantage. So with a single pumping station, we can operate about 75 educated wells. That is the advantage of this jet ejector system or educated system. Now, in this system, we have the vacuum or ejector uh, system, and then a controlled pore pressure, and then the soil, and the extracted groundwater, and generation of vacuum, and drainage system, and then the working. How this working occurs? See, this is the jet, which is pumping the water at great pressure so that it is moving the water. So this picture clearly shows that there is a nozzle. There is a nozzle at this point. So the water and high pressure. The red line shows the water and high pressure, and blue line shows the groundwater. So that this red line shows the water ejecting from the nozzle, and because of that, there is a vacuum created here, so that the groundwater is also sucked and sent to this one, thereby you are able to pump out the water even from the fine grained soils. That is the advantage. So here you can see that one bigger plant is available on the ground level, and it is connected to mini ejector pumps or jet ejector system. Thereby, easily we can have a drawdown of 20 meters or 30 meters from the existing groundwater table. So this picture shows that the adder pipe and the ejector pump, and thereby the water is pumped from many well points. So this is the closer picture of that system. So here also we can see that it can be completely closed, and there is a pumping station. Here a lot of pumps or pipes are available with single header pipe, so we can easily make the groundwater table go to the greater extent. Now, what are the advantages of this educator system or jet ejector system? They are very flexible in level and layout. So we can put at any point, and it is stable in operation, and it is able to run dry without damage. So sometimes, some other cases, if the water is not there, if the pump is running dry, then it cause damage. Whereas here it is not so, and not limited by depth. It's not limited by depth, so it is very effective to a great depth, and it is very best in low yielding wells. That is, when the soil is fine grained soil, the yield will be less. So in that case, we have to go for this type of system where we can have lot of discharge, and it is energy intensive. That is, it is energy economic, and eventually at the base it is creating vacuum, thereby it is sucking the water from the soil. But we have to take care during these dewatering techniques or dewatering operations, because these dewatering activities may erode the soil from the construction site. So if you don't do it properly, then again there may be settlement of the structure. It is also important to choose the best location for discharge. We should not excavate or the pump out the water and put the water very near to the well point. It should be discharged at a larger distance so that it is not going to again increase the existing groundwater table. So that is one of the important points that you have to look into. And also, water should not be pumped out directly into the slopes, because again slopes may subside. And we have to pay special attention and discontinue dewatering if any of the area shows sign of instability or erosion. That is very important. So we should be very cautious that during the dewatering stage or dewatering process, is there any substance occurring or not? Sometimes channels used on dewatering must be stable, otherwise it may also collapse. And whenever there is a heavy rain, we have to avoid dewatering because the infiltration rate is at a minimum and water will move slower. So we have to avoid during that time. And we should not discharge water that has been contaminated with oil, grease, or chemical products because again that is going to cause pollution at the point where we discharge this pumped out water. Otherwise, we have to make necessary steps to separate the oil and water and then only discharge. And we have to get the permits and requirements from the state or local agencies whenever we do this dewatering technique or dewatering process. So this knowledge of the permeability of the soil will give us what type of technique that we can employ for doing this dewatering. Normally, this clean gravel will be having the coefficient of permeability K at a rate of 10 power 1 to 10 power 2. That means the drainage property is very good. And in case of medium and coarse sands, it is 10 power minus 2 to 10 power plus 1. So the drainage property is good. Whereas in case of loose silt or fine sand, it is less. That is 10 power minus 4 to 10 power minus 2. So the drainage property is very bad. Whereas in dense silt or clay silt, it is even further less, resistant power minus 5 to minus 4, so the drainage condition is very, very poor. And silt and pure clay, it is around 10 power minus 8 to 10 power minus 5, it is very, very poor. That is, this is the coastal permeability, which is in terms of meters per second. This picture shows clearly that how much drawdown we can have with the different techniques. So here in the y-axis we have the groundwater table from where from 0 to 5, 10, 15 and 20, and in x-axis we are having the permeability in terms of meter per second. So here where we have to go for. For example, if you want to have a depth of drawdown 5 meter, then we can go for single stage well point. Whereas when we want to go for more than 5, maybe 10 meters, up to 10 meters, then we have to go for two-stage well point system or deep wells. Or when we want to go further, maybe more than 10 meters, then we have to go for deep wells. And this is in case of what? 10 power minus 4, that is silty soil. And here, this is in case of coarse sand or gravel. Whereas if the permeability is in this case, that is 10 power minus 5 to minus 7, that means it is completely clay. So in that case, you have to go for only jet ejector system or educator system, then only it will be efficient. Otherwise, it will not be efficient. So we have to be energy efficient. At the same time, we have to see the project cost. At the same time, we have to see what is the drawdown. Accordingly, we have to fix a particular technique or adopt a particular technique. Thereby, we achieve the required depth of drawdown or required depth of groundwater lowering. Thereby, we can continue with the operation, that is construction